All right, in this problem, our setup is that we have a capacitor with a distance of 5 centimeters between the two plates, and we're going to consider the potential and the energy stored before and after we slide the dielectric material of glass in between these two plates of the capacitor. So some helpful equations we'll be using are delta V equals delta U over Q, the potential in the vacuum over K, the dielectric constant equals the potential of the insulator, and E naught equals potential over delta X, and lastly that the E applied over K is equal to the E net insulator. So to begin with our initial conditions, our original potential is going to equal 20 volts, the dielectric constant K is equal to 2.5, and the thickness of the glass that is being slid in between these two plates is 1 centimeter. Our first step is to calculate E naught for the glass is slid in, so that is going to be negative 20 volts over 0.05 meters, which is the 5 centimeters. Which is equal to negative 400 volts per meter. So from this, we can then calculate the E net of the insulator. So that is going to be our negative 400 over our K, which is 2.5, which is equal to negative 160 volts per meter. So now, considering the fact that we slid this glass in, our new delta X for the air is going to be equal to to 0.05 minus 0.01, because 0.01 is the thickness of the glass, centimeters. It's going to be 0.04, which we will plug in later. And then our delta X of the glass is going to be equal to 0.01 centimeters. That's just its thickness. So with all of this, we can consider the fact that potential is equal to the negative electric field dotted with the change in position. Now in this case, we can just consider the magnitude of the electric fields and the change in the x direction, because we are saying all of this is happening in the x direction. So our new potential is going to be the potential of the glass and the potential of the air added together. So the potential of the air is going to be E naught times delta X, which is going to be 400 times 0.04, and then we're going to add the potential of the glass, which is 160 times 0.01. We're going to factor out a negative out of all of this, because all of our potentials are negative, and potential is equal to negative E times delta T. Or delta X, sorry. So when we add this all up, we get 17.6 volts. So this makes sense. We have slightly less potential than we did in the beginning of 20 volts. And if we relate that back to the energy stored, we can see that the potential is equal to energy stored over Q, so that means potential and energy stored are directly related.